All right, page 167 in your textbooks, you had 5 problems for homework numbers 11 through 14 and 16. At least one of those you knew had to be a double triangle. And, oh, there's 16. And so we'll take a look at these problems in a moment. All right, number 11. Again, all of these are going to be side-side angle because they're in the side-side angle section. We know that. So the question comes for all of these, what kind of angle are we dealing with? And number 11, we're dealing with what type of angle, class? Acute. How does opposite compare to adjacent? Is smaller, and that always means more work. So we now have to compare the opposite 488 to the adjacent 1464 times the sine of 23. And how does adjacent or opposite compare to adjacent sine theta? Still smaller than that, which means no triangle. Okay, so we go to number 12. That was easy enough. Number 12. What type of angle? Right angle. And opposite compares to adjacent how? They're equal. Wait a second, though. The opposite of a right angle is called the hypotenuse. Hypotenuse has to be the biggest side. It can't be equal to a leg. So the verdict on number 12 is no triangle. Number 13. We have what type of angle? Acute. How does opposite compare to adjacent? Are you allowed to do that with an acute angle? Yes. Sure. It just means you're going to have what type of triangle? Isosceles. So as I look at this, we're going to use the law of sines. A over the sine of A equals B, which was 24 over the sine of 28 degrees equals C, which was 24 over the sine of angle C. However, I don't need to use any calculator to get angle C.
Or 28.
I already know it's going to be 28 degrees. Because if the two sides are both 24, the two angles have to be the same. So my first angle, piece of cake. Second angle is also going to be pretty easy because together this adds up to 56 degrees. I'm only allowed to have how many in the triangle? So that leaves how many degrees here? 124 degrees. We could, well, we have to round that off though, don't we? 120 degrees. We're going to say 124 though for sake of the calculation. So we actually only have to, we might have pulled the calculator out for the 124, but we only have to pull the calculator out for this one calculation. We're going to cross multiply here the sine of the 124 times the 24, divide out the sine of the 28. And what do we get for side A?
42.3.
Right, 42.38, blah, 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 rounded to 42 units. And it makes sense. This angle is significantly bigger than the others. It should make sense that this side is significantly bigger than the others. But it is still less than the sum of the other two. It has to be less than 48, and it is. Do we get these 3 answers for angle A, angle C, and side A? Any questions? Number 13. Number 14. We have what type of angle? Acute again, just like numbers 11 and 13. How does opposite compare to adjacent? It's less than, just like number 11. So now that means more work. We have to compare the opposite to adjacent times sine theta. So we're going to take the adjacent 622 times the sine of the 25 degree angle. How does opposite compare to adjacent sine theta? It's bigger, which means 2 triangles. If it were equal, it would be that magic perfect length, but it's bigger than magic perfect length. It's going to make 2 triangles. So for the 2 triangle, I said you're going to want to start with a sketch. So we're going to start by drawing a 25 degree angle, and we're going to name it B. Doesn't have to be a perfect 25 degree angle, but it should look sort of close-ish. And our adjacent side going up the hill is going to be side C. That's the 622. And again, magic perfect length would have been 262.8. But instead of being 262, I had 311. I had a good bit bigger. So my line is going to come in and go out the same amount from my perpendicular. And both of these lines get called B, which is the 311. These have to be side B because they're across from angle B. Well, if this is side C, then this angle down here has to be angle C. But there's a second angle C. We're going to call it angle C prime, and it's going to be, remember, this obtuse angle here. Did we get both of our angle C's labeled correctly on the picture? That means at the top of the triangle, we have angle A. And remembering that my second triangle is just this little side piece here. That means that this angle has to be angle A prime. So we have A prime, C prime, B. We have the whole angle A, the angle C, and the angle B. Also, that means that just this little piece from B to C prime can be named little a prime, and from B to C gets named little a. Little a prime. Sounds like a rapper's nickname or something. Anyway, so little a prime and little a. Anyway, I digress. We are going to still use the law of sines to solve, and when we use the law of sines, of course, it's always going to give us the big triangle. So that's where we're going to start. Specifically, we're going to start by finding angle C, because we already know B, angle B, and C. So of course we're going to start here with angle C. Once we found angle C, we need to make sure we put it in the memory. So, what did you get for angle C? Yeah, 57.69, blah, blah, blah. You rounded that off and said 58 degrees? Yes, because angles are 2 sig figs. So 58 degrees, but you put the exact number into the memory of your calculator, as you did this yesterday, or in study hall last hour. Then we use angle C, which we just found, and of course angle B, which we were given to get angle A. And plus 25, and then subtract that from 180. And what do we get for angle A? 97 degrees. 97.32, blah, or 0.30, blah, 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 but rounded 97 degrees. Then we're going to use this exact value. We don't have to put it in the memory because it's still on the calculator. We'll take the sine of it times the 311 and divide out the sine of the 25 to get what for side A? 729.9, or we'll just round that 3 sig figs though, 730 point to get the third sig fig. And there's triangle number 1. We were good on triangle 1? All right, now as we come to triangle 2, the first thing we must find, we're going to find them the exact same order. But it's not angle C, it's angle C prime. It's not angle A, it's angle A prime. And not side A, but little a prime. How do I find angle C prime? It is supplementary to this guy, because these two angles are equal because they're opposite equal sides in a triangle. So because these two are equal, and these two add up to 180, these two add up to 180, we're going to take 180 minus that value that we strategically put in the memory to get what for angle C prime? 122.30 dot dot dot. Rounded 120 degrees, because again our angles only get 2 sig figs. Our sides are getting 3, but 120 degrees. Then to find angle A prime, we're going to take the 25, not yet law of sines yet, we're going to take the 25, we're going to take the 122 that's still on my calculator, add those, subtract from 180. How big is angle A prime up here? It's going to round to 33 degrees. It's 32.697. And I'm going to come back here, and instead of the 97.3, 32.69. And of course that's going to change my A, so we'll take the sine of that angle times the 311, divide out the sine of 25. And what do we end up with for side little a prime?
398.
Rounds to 398, 397.52, blah, blah, blah. Were we perfect on both triangles?
I have 122.
Okay, so just a sig fig error there. And use perfect error. Outstanding questions on the double triangle. I think number 16 was also double triangle, but let's find out for sure. Oh, sure, it's gotta be. It's gotta be double triangle with those numbers. All right, what kind of angle?
Acute.
Acute. And how does opposite compare to adjacent? It's less, but it's not much less. So I'm reasonably sure this is going to work out. We then have to compare to adjacent sine theta. So we're going to take the 40 times the sine of 60. Ooh, it didn't make it by much. It is greater than adjacent sine theta, just barely. Adjacent sine theta came to 34.64. This is 35.3. We just made it. All right, so we do get the double triangle. Now for this one, we're going to start with our angle, which was 60 degrees. That's a pretty steep starting angle compared to what we usually have. Again, straight down would have been the 34.6. It just barely bigger. So it just barely comes in and goes out on both sides. I guess you don't really need all of that. All right, so this angle was named angle A. And these side A's, I'm going to write it kind of along the line here. A was 35.3, and A is 35.3. All right, now this side was called side C, and that was 40?
Yeah.
40 point?
Oh, yeah, actually. Yes.
Okay. All right, which means that down here, this happens to once again be angle C. Not because it's always angle C, but because this is called side C. If they call this B, this would be B. And that means that this angle is C prime. Up at the top, we have angle B, but this piece is angle B prime. And then this little piece from A to C prime, little b prime, and from A to C,
I know it's
little b. All right. I tell you. Anyway, all right, so again, we're going to start with the law of sines. Yeah, we got 35.3 over the sine of 60 equals b over the sine of b equals 40 over the sine of c. And once again, the first thing we'll solve for, angle C. And when we solve for it, we got to put it in the memory. That's a pretty steep angle as I've got drawn here, right? It comes out to
78.9.
good, and I'm going to say, since I always do at least 2 sig figs, they only gave me 1 sig fig on angle A, but we always do at least 2 in this class. So we'll say 79 degrees, 78.911. So we'll store that in the memory, remember. Then we'll find angle B. We've got these two, get angle B to be what?
41.0.
Good, almost exactly 41 degrees, comes to 41.08. That doesn't need to go in the memory because I'm going to use it right away. We were given the A ratio. We just found the bottom half of the B ratio. Let's find the top half. Take the sine of the angle on the calculator times the 35.3, divide out the sine of 60. And what do we get for side little b? Good, if we go 2 sig figs because of side C, not the 3 unfortunately I would have liked to use, we'll have to say 27 for side B. And there's the first triangle. Are we good on triangle 1?
I could say those significant.
Sig fig errors, but otherwise good. All right, now we're ready to go to triangle 2, which means I'm going to have to start by finding angle C prime. I start with the bottom corner, then I go to the one that is supplementary to it. So how big is angle C prime? Oh, that's annoying. 101.08 blah, blah, blah degrees, but I've got to round that off to, well, that's only 1 sig fig. 1.0E2 degrees. That's just infuriating. And they couldn't have done 60.0 degrees. No, they couldn't do that. All right, 1.0E2 degrees. That's just obnoxious. Then we need to find angle B prime. And so I've already got the 101 degrees here. I've got 60 more degrees here. That leaves how many degrees for angle B prime?
19.
We'll say 19 degrees. It's 18.91 blah, 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 but whatever. All right, and that allows us to find, there we go, little b prime. Just kept waiting for that one. And we will take the sine of the 18.91 times 35.3, divide out sine of the 60, and what do we get for little b prime? Oh, that's true, 13.211, but rounded 13. And there are our answers for the big triangle. How do we do on that, other than maybe sig figs? All right, so we've got the process down for what we're doing. Obviously got to watch sig figs, but we've got the process down on how to solve a double triangle. Not nearly as hard as maybe we at first feared. All right. Well, let's do some more review then. You can set your books aside now. I'm going to put some problems on the board. I'm going to jumble them up. So we've been, again, all we did last night for homework were side angle. Want to make sure you're able to spot side angle when you need to and tune it out when you don't. So I got 6 classwork problems for you. 7 classwork problems. Well, I'll tell you what, I'll start with 4, and then as we work them, I'll erase and put new ones up. All right, so we got an angle B of 140. Side B is 13. Side C is 18. A 49-degree angle. Yeah, I'll put one more. I got room. I'm going to start putting up answers on the board. Except we'll go with a little blue chalk. Just cuts. check answers to the first 3 problems. Did we get no triangle on the first 2? I just missed, by the way, this one here was like 6.9 was adjacent sine theta. Like, man, just missed it. But hey, the lazy side of me is like, yeah, but now I don't have to solve 2 triangles. So I'm like, I don't mind putting no triangle. And then on the next one, we did have a right triangle formed. And did we get those answers for angle A, angle B, and side B? All right, I'm going to erase these 3 while you finish those 2. I've got a couple more to put up. Are we finished with the original 5 yet, or are we still working? All right, you're finished with the original 5. Again, there's 2 more up there. How do we do on the side angle and the side angle? Good on those?
You got my A's wrong.
All right, let me take a look at yours. You can continue working, Jamie. All right, so coming back, where are we at? This one? 72. Yeah, just a subtraction error. And that, of course, is going to mess up your side A as a result. But that would be the correct answer if angle A were the correct answer. So, yeah, just be careful. Did you use your calculator or tried to do the 72 in your head?
I think I used my calculator.
180 minus 43 minus 59. Maybe his calculator entry here. All right, we'll
Yeah, I
move on.
got that one.
Good. All right, so we'll move on. Obviously, if you're watching on YouTube and missed any of these and you can't figure out your own mistake, obviously the goal would be to figure out your own. But if you couldn't figure out your own mistake, reach out to me, get some help. As is always the case with anything we do. Floundering is no good. Getting help is helpful. Deep statement for the day. right, so far so good. Are we good to go on the angle side angle problem?
Yes.
All right, and then we figured out 2 triangles on this one, I presume. And we got the first triangle, so far so good? All right, so let me go ahead and find the remaining pieces then. We'll start with angle B prime, which will be 130 degrees. It's really 130.24. Angle A prime then will be not very big. It will be 10.4 degrees, that's 10.358. And then little a prime will be not very big either. It'll be 2.61 centimeters. 2.614 blah, blah, blah. Make sure those numbers add up. And they do barely. Yeah, it seems like that should work out. You good to go on those numbers? All right. Any questions at all on the law of sines? Because that really concludes everything we would use the law of sines for. Questions at all? All right, clear it is, except for a clean sheet of paper, a pencil, and calculator. Clean sheet of paper, pencil, and calculator. Everything else away. Clean sheet of paper, pencil, calculator, everything else away. First one, let's name at the top of your paper along with today's date, which is 1/11/22. 1/11/22, today's date. First and last name, 1/11/22, and this is quiz 25A. Quiz 25A. As we wrap up law of sines. By the way, there will be no homework this evening. We'll go ahead and get into the law of cosines tomorrow. So tomorrow I'll give you a small homework assignment, but no homework this evening, for me at least. And that way it kind of gives us a good transition here. All right, quiz 25A. Very similar to the last quiz in that you have 5 triangles to solve, if there are triangles, of course. Solve for the missing parts. Of course, if there's no triangle, just write no triangle. If there's 2 triangles, make sure you solve both. Make sure you solve all the missing parts. Be careful with your sig figs on this. All right, you may begin. And that'll end the video lesson as well.